if you see the global irrigation map, very clearly this region is seen as the most irrigated region in the world. And if you relate it to the population, also you see this is the most populated region in the world. So this is a very important area: mountain surface, water coming down, irrigation, and related food security. I think this is the topic that we have to keep in mind. Then this was mentioned in the morning also. Apart from two poles, this is the area where there is highest mass of snow and glaciers in the form of fresh waters, and there are many wetlands, and in the context of climate change, these are the ones which are impacted immediately, which we can see visually. When we talk about wetlands, I think there is a Ramsar Convention, and most of you know about that convention, and many of the wetlands which are distributed are shown here. Those blue spots, all these blue spots are actually the wetlands which are mapped, but the red and yellow, if you see, are the wetlands which are the Ramsar sites. And the Ramsar site, which is at the high altitude, are the yellow ones, which is very, very important in terms of management and coordination in the region. And these are the wetlands which are also as a form of storage, which actually governs the hydrological cycle, and water discharge downstreams are actually governed by these wetlands. Then in 2007, IPCC report, assessment report 4, very clearly showed that this region is a data gap region. And ICIMOD started working on this, and I'm very pleased to tell you here, now we have the data for the entire Hindu-Kush-Himalayan region in terms of glaciers. You can see all these countries. Now we have this 60,000 square kilometer area on glaciers that's been mapped. Another map, if you see here, we have also on weekly basis, from 2000 to 2010, we have been able to do the snow cover change detection through MODIS. And for 10 years we have this data. And I am also very happy to tell you here, this MODIS is a very sophisticated system for Hindu-Kush-Himalayan region. We are installing that system now in ICIMOD, where you will have more accuracy in the future. It's a very important structure that is coming for this region. Then we also have done the glacial lakes mapping, and if you go from east to west, you will see the glacial lakes very much here. And if you see the Brahmaputra basin wise, it's the largest number of glacial lakes are actually here. So Eastern Himalaya is having more glacial lakes. This also gives us an indication that there is more warming here, and also as we go towards east in the Hindu-Kush-Himalayan region, you are more in the tropical latitude. So because of that, you will see more lakes rather than actually the glaciers. This is also finding that we have been able to do. Lastly, I would like to mention here, in the context of climate change, Professor S.P. Singh is here with him and team. We have actually come out with a status of climate change report for the Hindu-Kush-Himalayan region, and it was released in Durban in COP17 in December. So that is also available. You can see our website and clearly see what has been the trends of climate change, what is the impact, and what are the responses from this region, and way forward for the region in terms of actually mitigating as well as meeting the challenges of climate change. So you can see some of these reports already online in ICIMOD. Now, another aspect of the Hindu-Kush-Himalayan region in terms of its importance is biodiversity. There are 34 global hotspots spread all over the world, and mountains are the hotspots if you see in general. But you can see here in the Hindu-Kush-Himalayan region, 4 out of 34 global hotspots are here. But the irony is that people in the mountains are very, very poor. That means very clearly we have failed somewhere, that our resources and development has not gone together, and we could not bring the benefits to the mountain people in spite of so much of water as well as biodiversity resources that we have in this region. So this is the challenge, that is the background on which we have to work. Now, change that we are seeing. Climate change is an important driver which we have realized recently. So now let me take you through the change of climate that we are seeing, and actually it's not a new thing. Climate change is nothing new. It has been changing over the years. The only worry is the rate of change. which we are seeing now. It's very, very fast, and you can see towards the end of the graph how fast it is heating the global Earth system. That is what is worrying actually. So the change is taking place, but if you see this particular picture here on the top side, 2020 to 2029, and then if you compare it to 2090 to 2099, very clearly you see there is a very distinct increase in temperature. And if you see the lower side, the precipitation rainfall, very clearly in winter, precipitation is going to be low, less precipitation. And in summer, there is going to be an increased precipitation. This is the global circulation model that has shown. But we have to work more those circulation models to bring it at the regional level to show reality and even go down to river basins. That is what ICIMOD is doing. And in this very clearly see annual surface temperature from 1961 to 1990, which you are seeing on the higher side in different models which we have seen. And you can see down below very clearly there is a projected change for 2030 with respect to what we had at 1970, and very clearly we see there is a very distinct warming taking place. And in terms of rain, summer monsoon rainfall you can see here, and again projected for 2030, but I can explain that much more better by this slide. If you see altitudinally from the most plain areas to high altitude Trans-Himalayan region in Tibetan Plateau, the temperature rise is very distinct. If you see annual temperature rise also, it's actually rising more in higher altitude. So temperature in Nathula rise is much more than what you have in Singtam. So that is the type of trend that we are seeing. And interestingly, if you see the dotted line is the winter. December to February is the dotted line, and you see the most change in the high altitude area is during that period. That means winters are very mild in high altitude areas. This is a very interesting slide in terms of climate change again. Number of warm days, if you compare the first graph. And here you see 1976 to 85, then 86, 89 it is increasing, and now 96 to 2005 it is further increased. So there are more warmer days, continuous. And if you see another number of warmer nights, again the trend is increasing, means it's already increasing like that. And when you see the maximum number of consecutive dry days, actually wet, 1976, 85, they were more wet and it decreased. And then if you compare the dry period, then it is increasing. So clearly you see there are more longer dry spells coming, and both nights and days are becoming warmer overall. So this is something which is quite alarming that we are seeing in a program which we actually selected in Shangri-La area of Yunnan in China, as well as Northeast India, as well, and then Indus, Upper Indus in Pakistan, and some parts of Nepal.